in example number 3, I'm going to solve two different problems using two different methods here. So we'll first start with our first problem, and as you can see, I've duplicated it, and I want to show how we would derive the same answer just using our two different methods that we've learned in example 1 and in example number 2. All right, so let's go ahead and start off with example number 1 and with method 1, which is first is simplify the numerator and the denominator fraction, which they are, and simplify meaning that they can't be reduced and they're only one fraction. Once you have that, now we're going to go ahead and multiply them by flipping the denominator. Okay, so 1 over p minus 6 times that by, now let's go ahead and take the reciprocal of that, p squared minus 36 all over 5. Okay, now we need to realize that this right here can be factored. This is a difference of two squares. So I'm going to rewrite my left one again, p minus 6 times, I can rewrite that though as p plus 6 and p minus 6. And as you can beautifully see now, we have a little cancellation, leaving us with just p plus 6 on top, all over 5. Okay, so we should get that exact same answer when we do the same problem over here, just with a different method. Okay, so now this method is we take our common denominator between p minus 6 and p squared minus 36, and then we multiply that by each numerator and denominator. And so our lowest common denominator is going to be actually this, right? Because if you think about it, this right here means p plus 6 and p minus 6, right? So this one already has a p minus 6, so it just needs a p plus 6. And so basically that's all I'm going to do there is the common denominator is multiply these each. Okay, so I'm going to multiply this by p plus 6, p minus 6, and I'm going to multiply this by p plus 6 and p minus 6. All right, so when I multiply this through, what we can see here is that p minus 6 cancel, and then all I have on top is just the p plus 6. See that there? All I have is p plus 6 times 1, which is that. And then here, see, p squared minus 36 is p plus 6 and p minus 6. So this actually cancels out with that, because this is the exact same thing. And all we have is just 5. Right? And look at, oh, you a trick of me. See? And there we go. See how we have the exact same thing on both of them. So in this case, it seemed like it's a little easier to just do method number 2, where I just multiply each numerator and denominator by the common denominator. Okay, let's just do one more like that. This one's got a little bit more hairiness to it, but we got this. Method 1, we first need to simplify the numerator and the denominator. All right, and so by simplifying this one, I need to multiply, let's see, the common denominator for, if I'm just looking at the numerator, is m squared n squared. All right, so let's go ahead and do that then. I'm going to multiply this in order to have a common denominator by m squared, and I'm going to multiply this right here by n squared. See, and then now they have a common denominator. If I do that, I have n squared minus m squared, all over our common denominator of m squared n squared. Okay, so there's the numerator. Now if I want to simplify the denominator, I need to get a common denominator. So the common denominator is mn. So I'm going to multiply top and bottom by m, top and bottom by n. So I get n times 1 is n, 1 plus m is m, so that's n plus m all over my common denominator of mn. Oops. I went too much there. Let's try that again. There we go. So let me just erase that there. mn. All right. Excuse me. So now we can do, so that was step 1, is first simplify each numerator and then denominator. And now I'm going to go ahead and do this by multiplying by the reciprocal. So let me rewrite this. N squared minus m squared all over m squared n squared times that by the reciprocal of this. So it's mn all over n plus m. Okay. A few things here. First of all, we have 1m and 1n on top, and we have 2 m's and 2 n's, so I can cancel that m out, and that would get rid of that 2 and that 2 there. And then notice that this is a difference of 2 squares, so this is the same thing as saying n minus m, n plus m. See that right there? So I could just cross that out because this is equivalent. So n plus m, which means that we're now left with just n minus m, that's on top, and in the denominator it's mn. Cool. All right, so method 2 now is multiply both the numerator and the denominator by the common denominator. Okay, so let's go ahead and do that there. And our common denominator is m squared n squared, right? Because if I look at m squared, n squared, m, and n, the least common denominator is going to be m squared, n squared, okay? Same thing right here, multiply that by m squared, n squared. All right, so if we look at the numerator right here at this top, m squared, n squared, times that by 1 over m squared. I'll just show it here instead of, I'll just do it. M squared, n squared, all over m squared, minus, and then multiply that through. M squared, n squared, all over n squared, right? And if I do that right there, and if I simplify it, those cancel out, and I'm left with just n squared minus m squared. Okay, so I'll just leave that there. That's the numerator. Now let's go ahead and multiply the denominator through. And that's m squared, n squared, all over m, right? Because I multiplied this by 1 over m. And that's why I get this. Plus m squared, n squared times 1. That's just m squared, n squared over n. Sweet. So now let's go ahead and multiply it through. So I have cool airplanes going by. So m squared over m, cross that out, that's gone there. N and then n squared, so that's gone right there. So all I have left is mn squared, plus m squared n, Okay. All right, so let's bring this down here. So what can I do here? Well, look, on top, I can factor that to be n plus m, n minus m, right? Difference of 2 squares. And then this guy, they have a common, I could factor out a common multiple of 1m and 1n. 1m and 1n. So if I factor that out, I would have 1n left. mn times n is mn squared plus, and then here I would have an m because mn times m gives me back m squared n. And what do you know? Check that out. And I'm left with n minus m all over mn. And that's exactly what we wanted to find.